All right, welcome back, ladies and gentlemen. I hope you guys are having a good time at RAISE 2025. Yes? Are you guys having a good time? Fantastic. So we now move forward with the masterclass on agentic AI in financial services, what it means in practice, how it changes the core workflow, and what institution needs to be preparing for it right now. Leading the masterclass are two practitioners driving real adoption in the industry. Mr. Swaminathan Iyer, the Senior Director for Cloud and AI, Microsoft India and South Asia, who works directly with the large financial institutions on AI transformation at scale. Joining him, ladies and gentlemen, is Mr. Murari Ramuka, Senior Technology Strategist at Microsoft, focused on translating AI capabilities into operational systems and measurable outcomes. Ladies and gentlemen, please put your hands together and welcome on the stage Mr. Swaminathan Iyer and Mr. Murari Ramuka. Welcome, gentlemen.
So, am I clear? Such a privilege to be here. And as a technologist, great times to live in. So much happening in the world of technology today, right? I mean, look at it. Um if you look at why we are in this room together, right? I'm a big believer that if we are in this room together, there is something more of an important work to be achieved, something more towards the future. And if you look at it, the future is already here. And when I say the future is already here, it's just not evenly distributed. And events like these, interactions, I learned a lot in the morning, help us just make sense of a very complex present we are living in and make sense of what may come in the future. And here, we're talking about three things today. One, why is this moment of AI important for us? Second, what are we seeing in financial services? And what can you do about it? Right? I think that's the three things we want to look at. And if you look at it, right, there have been multiple platform shifts in technology that have happened. But why? And each of these platform shifts have actually created value and left very consequential companies. And each of these platform shifts have really changed and created value for the world. But what's different in this AI platform shift? What's really different? What's happening here? Three things, if you look at what's happening. One, all of the past four technology shifts were about democratizing technology itself. But this shift is about democratizing knowledge. Knowledge in the area of healthcare, knowledge in the area of financial services, knowledge in the area of financial crime. It's democratizing that knowledge. The second part, this platform shift is actually compounding the effects of all the three of the other four platform shifts that have happened in the past. It just leverages those four to accelerate. And the fifth, the spirit of the times. Every CEO I speak with, every CEO in the country, every CEO is now looking at saying, what can I do with AI? How can it help transform my business? And these three things together, democratization of knowledge, building on the other four platform shifts that have happened in the past, and just the spirit of the times, is where we're going to be creating history. And this is such a great time to live in. If you roll over, I'll just give you an example. There's a very interesting benchmark called the Google Proof Q&A. Anyone heard of it? So I'll tell you what, it's a very interesting benchmark, which is a set of questions that you can't Google the answers to. So they took a bunch of PhDs, some, and gave them internet access. And some, they had said, OK, this is the domain you belong to, and this is the domain that you don't belong to. For people who did not belong to the domains in which the questions were designed, they scored 31%. For people in the domain itself, they scored 81%. And look at what a reasoning model like O3 did. It scored 87%. And that's like 0.1% of the population with an IQ of 150. If we were to take this room, top quartile, IQ will be at about 100. Maybe I'm the one who's pulling it down. But what if I told you, right? This model, which is at 150, I lend you 50 IQ points more, which puts you in line with a Bill Gates, a Stephen Hawking, or Bobby Fischer. Would you not take it? 50 additional IQ points to your existing IQ. And that's the moment we're talking about, that's the shift we're talking about. If you go further, right, what's really driving this platform shift? Three things. Models are becoming super intelligent. They're just scaling really rapidly. Every few months, there's changes, and the models are accelerating their own level of intelligence. Second, we're seeing a lot of optimizations in software itself. And what's happening with software? You're typically putting in more inferencing power to AI applications that are running. And the third is GPU compute power. That itself is doubling. So all these shifts put together are actually driving the entire AI platform shift. Just And this was a very interesting quote by Sam Harris, American philosopher, who said, intelligence is a beautiful property given only to humans. That may not be true any longer because we are creating machines that are, if not equal to humans, at least getting there. And if you look at what's happening today in the industry, there's two things, right? Intelligence is available on tap. Earlier, to get intelligence, to get work done, you hired people. You hired teams to get work done. But now, intelligence is available on tap. Organizations together are teams or bunches of clusters of intelligence that work, and that's where the future is getting to. And now coming to what we're seeing in financial services, I'll just roll a video on what are the questions financial services companies are answering today with AI. And that'll give you an intuition of what's really happening in the world today. Roll the video.
Real value for our customers. Unlocking financial services specific skills to meet your needs wherever you are.
And if you looked at it, I think the video can keep rolling. We're privileged to be seeing all of these use cases that customers are looking at in financial services. But what do you think is driving this? This is a very interesting metric and a study that Microsoft did, called the Work Trend Index. We publish it every year along with LinkedIn. We just looked at the capacity gap in financial services. 83% of execs believe that they just don't have the energy or the time to do the work they're supposed to do. Is just causing burden on the system. And if you look at the second part, it's about when you looked at saying, can we add a digital labor force in the financial services industry? About 82% of execs said, we're going to add agents in our labor force in the next 12 to 18 months. And don't mistake me why this is happening. If you roll over, the primary question to ask them was, when would you trust an agent vis-a-vis when would you trust a human? And three things, right? An agent that's available 24/7. The speed, quality, consistency of agents is something that someone can rely on because you're tired in a day, you just don't respond, productivity goes down. Agents perform at a very consistent level. And third, essentially saying, I may be down, but I'm getting a constant stream of ideas. So we're not really looking to replace humans, but saying, how can we augment it? It's not You can't just replace them, but how can we augment this entire force with the digital labor? And if you look at from where we're seeing this across the 3-year AI movie, which is like really popular now, the 3 sets of use cases we've been seeing, right? The way one use cases, financial services institutions typically used AI for internal purposes. They looked at productivity of how can we improve productivity of their own employees. And slowly, wave 2 started happening, where we said, OK, can we get to the customers? The amount of conversations I have today on voice agents, on agents handling customer services, are just there, right? India is just booming with these use cases today. And the third part, 2025, as we call it, the year of agentic AI. The trust in these systems is going up to start saying, hey, can we build intelligent systems that once I give direction to, they help increase efficiencies in these processes. And wave 4 is we're fortunate to have some of these conversations with our customers to talk about what may truly be. We don't know what the definition of AGI would be, but then are we implementing those use cases, self-healing core banking systems? We don't know how those future will emerge. But then we be at a vantage point to start having this conversation with customers. And if you look at it, 3 main models that I look at how agentic is emerging in financial services. One is you had a human who's controlling what an agent did. You gave it a task, it did the task for you, it summarized a document, it wrote an email for you, it did the basic part of it. The second part is all about building teams, building digital employees. And we're seeing a lot of these use cases right now, saying, give an agent a task. It should be able to go sift through the noise in the organization, sift through the data, sift through the systems, technology, get you an answer, reason over it, and say, hey, boss, this is what I found. And you typically tend to be an agent boss. And the third area is all about setting a direction for the system to go ahead, and the system identifies and kind of encapsulates a goal-seeking behavior and says, these are areas that I can achieve. And to just show you what we're seeing in that space, I'll invite Murari to show you some demos on what we've been seeing and working with customers in multiple areas.
Sure. Thanks, Swami. Good afternoon, everyone. I hope it was interesting. So what we are talking about here is agentic, right? And this is one of the, I would say, most popular world as of today, right? Even though we don't know maybe what is generative AI, but everybody want to hear and try something around agentic, right? So that is the world we are in. And as a frontier organization, what Microsoft believe is there are 3 areas, right? And when we talk about the journey, it starts with phase 1, where we are talking about AI assistance, right? Trying to use some assistance in order to help you, right? And the second one could be around the human-led agent. It is still governed and managed by human. And the phase 3, where we are trying to go ahead and take it autonomously, which is we are trying to make something human-led, but agent-operated, right? And we are talking about the third, which is the autonomous agent as of today, because I think first 2 is almost solved, and people are looking and the organizations are looking forward for the phase 3. If I go quickly to the next slide, right? I spoke about phase 1, but phase 1 is something like AI assistant. At Copilot, maybe if you're using Copilot, there are so many things which you can quickly do, right? Starting from, if I take a payment lending journey or payment lending manager, the task could be something product development, onboarding, all those are very easy with AI assistant, which is nothing but the phase 1. If I go to the phase 2 is more towards the human-led agent, and what we are talking about is how does we can go ahead and use those agents to go ahead and make something which is human-led driven decision. And if you see a couple of examples here, and I have tried to put it into a landing world, that how does the phase 2 looks like in agentic orientation, right? If you see, it starts with client advisor who gives a request starting from uploading the document, and then there will be a client advisor portal which starts from onboarding the customer. There will be an orchestrator, and this orchestrator, if you're talking about multi-agent terminology, definitely is one of the very important thing, because it decides that where, depending on to the context of the question, should go ahead and ask and bring that agent in the picture. So it starts from orchestrator, then it goes between multiple different agent, what we call it is a web of agent, where they are classify agent, they are document extraction agent, and there are so many other policy check agents, because if you're talking about the landing journey, definitely one of the very important aspect is the underwriting, right? Trying to understand the document and seeing that whether the document which has been submitted is complying with the requirement or not. So again, this is the phase 2 which we are talking about, which is human-led agent. Let's go to phase 3. And under phase 3, if you'll see, right, we are talking about a complete orchestration or complete journey, which starts from maybe customer starts from maybe filling the application, trying to go ahead, and then the agentic flow comes into the picture, which takes the complete entire journey via the human-led agentic operated way of execution of that stuff, right? So here humans set the direction, but finally the execution will be taken care by the agent, which, and that's why we are talking about the autonomous agent. Again, there are multiple different tools, technology which are available within Microsoft, which enables you to go ahead and try to solve that autonomous agent, which is a phase 3 problem. What I will quickly do is now I will quickly go ahead and try to demonstrate it via a demo, right? So let me quickly go ahead and reshare my screen, and we'll come quickly here. Yes. So what we are talking about, and as I said, we are in phase 3, and we are talking about multi-agent, right? So if I go ahead and start with that, there are 3 agents which I am talking about, which is a customer agent, merchant agent, and fraud, right? Though if we talk about the complete retail banking, there are so many aspect where we can go ahead and use, but I am trying to demonstrate a feature of multi-agent which can be used for fraud analytics, right? So under one agent, which is a customer agent, there are again sub-agent. You can see voice agent, you have high level, medium level, and low level agent. This agent management console help you to understand what is the status of each of these agents, whether they are ideal, what is the confidence thresholds, etc. And if it is connected, because for real-time streaming data, if you are trying to run it, you definitely need something like a real-time streaming data, and it is connected through the event hub. If I can quickly project the architecture, that how does it looks like. So this is a high-level architecture. Okay, so it says that from the front end, we are ingesting the data which is coming through agent terminal via the Azure Event Hub. And then there are 3 different agents along with sub-agents which are coming into the picture, starting from fraud agent, consumer agent, and merchant agent. And all these agents are powered via the Azure OpenAI and something called as the time GPT. I hope everybody aware about that, which is a time series GPT model. So it is powered via the time series GPT model. So this is a high-level architecture which I'm talking about. So again, going back, there are 3 agents, and all you can see right now active. I have the option to restart and maybe get it going. Let me quickly go ahead and try to start maybe running that agent quickly and see how does it is working. Cool. So if you see, as I said, we have 3 agents over here, which I'm talking about. So in multi-agent architecture, you can see customer agent, right? You have something called as the event hub, which is basically helping you to process the data which is coming from the front end, okay? And then you have the fraud agent, and then you have the merchant agent, right? So let me quickly start, and I can see all these 3 agents are connected to each other. If you can see, there is a customer agent, merchant agent, and fraud agent. All are active, and there's no, what I'll say, message which are coming right now. So let me start it. And as and when I started, right, how does it happening is a customer is raising a complaint. What customer has said is someone used my credit card for 3 food deliveries, totaling while I was away and I was traveling. And he want to raise a dispute, which is a proper fraud transaction, which we call out, right? Again, what is happening is, if you see, there's a customer agent which is coming into the picture, and it is trying to find out the resolution for that particular customer. And if you see that it says that where it is right now, it is in low-level agent, and then after that, it is passing it to the fraud agent just to identify that whether that transaction is really categorized as fraud or not. Using the time series, then it passes to the merchant. Once it identified that yes, it's a fraudulent transaction, the message or the control has been passed to the merchant agent, and merchant agent is taking care of the refund. Again, once the refund is issued, the request is completed, and what is happening is dispute charges has been successfully blocked, and the amount has been refunded to the customer. So again, at a very high level, what I'm trying to show is that how these three agents, which is customer agent, fraud agent, and nothing but the merchant agent, is interacting to each other in order to resolve a customer query. Again, this is just a starting point, and I'm just took an example of fraud detection. There could be so many elements where you could use the multi-agent architecture to solve the complex problem. Let me go and try to show you something something interesting over here, right? So there's a dispute raised, and again, there's a complete orchestration which is happening, and with that, the transaction is basically getting wide, and the amount is being refunded to the customer, right? So that is how it is happening. If I go and try to just see that how does the fraud agents looks like, right? So if you see here, within the fraud agent, we have so much of transactional data which are there, which is a real-time data coming from the event bus. We have something called as the AI reasoning model, and I think Swami also spoke about it. We have one of the best reasoning model, and if I go ahead and just try to run the analysis on the transaction which has happened in the past and see that what is happening with my transactions, right? This particular model takes those data as an input, which is a transaction data, and give you a complete insight that whether that transaction was a fraudulent or not. Again, underlying, it is a fine-tuned time series GPT model, right? So what we have done over here is we have fine-tuned with a bit of data to identify that whether it's a fraud transaction or not, and it can go ahead and try to detect that transaction in real time and classify it as a fraud and non-fraud, right? So again, this is a standalone agent which I have shown you, but when it combined with merchant and consumer, it can help you to resolve any dispute-related query which is coming from the customer related to fraudulent. If you can see that it shows the accuracy and how many alerts has been done today, right? If I go back to the management, I can see that how these agents are interacting and how they are connected to each other. Because that is also one of the very important things which we want to see, that how the handover and how the communication is happening between the agents. And that's where you can see that under consumer agent, we have sub-agents like high-level voice and others, and whether they are connected to each other, whether they are connected to each other, whether they are solving the problem, etc. The second agent, if you can see, right, what this agent is meant for and what are the sub-agents, and I can see and identify the complete details of the connection matrix for these agents. Last but not the least, which is very important as an enterprise, is performance, right? Everybody will see, Murari, that's great, but how about performance? If I go and run any agent and takes 30 seconds to respond, no, I'm not going to use that. And that's where the performance matrix comes into the picture. And here, all the data which you see is something around millisecond. So we made sure that we provided the right set of infrastructure, underlying infrastructure, to make it something which can be solved within millisecond. There are a couple of metrics which has been shown over here is something around user metrics, request per day, how many alerts has been generated, and what is the system uptime, right? So this is just one part of it, but there are so many other things which can be done with agents, though I have just covered a bit of it, which is retail agent. But if we consider the complete financial sector or financial industry, we could have the agent applied on banking, mortgage, or insurance. With limited time, maybe we'll just cover the retail one, but happy to discuss in detail if you have any questions, anything related to mortgage and insurance, that how does phase 3, which is the multi-agent, human-led, agent-operated phase is coming up. So with that, thank you very much, everyone, and happy to take any question. Thank you.
Thank you so much for that wonderful, wonderful masterclass. Did you guys have fun? Learned a lot? Yes? Perfect. So, ladies and gentlemen, I would take this opportunity and welcome on the stage Mr. Sridharan Kannan, Head Internal Audit L&T Finance, to come on the stage and present a token of appreciation to the gentleman on the stage.
Thank you very much. Thank you.
Come on, let's have a round of applause once again for that wonderful masterclass.
Thank you. Thank you very much.
Thank you so much. Thank you so much. So, ladies and gentlemen, our next. So, ladies and gentlemen, our next session focuses on a core requirement for AI at scale: cyber resilient data foundations. Our speaker, Mr. Vasu Murthy, the Chief Product Officer at Cohesity, works at the intersection of data management, security, and AI deployment. He deals with the real operational challenge enterprise face when their data becomes both their greatest asset and their biggest vulnerability. Vasu is a proven product leader with over 25 years of experience building products at every scale: startup, day zero, growth, multi-product scaling, and global public companies. Please join me in welcoming, ladies and gentlemen, Mr. Vasu Murthy.
Thank you. Thank you very much. It's a great pleasure to be here. Thank you very much for the organizers. Thanks for L&T Financials. In this session, we'll kind of change the gear a little bit. Lots of applications have been discussed. I want to take it back a little bit to developers and infrastructure. Can I have a show of hands? How many people are developers here? Okay, you have a fair number of them. And how many of you have dealt with data and infrastructure? Even more. So great. I'm at home, right? I'm at home. Thank you. So the topic of this is cyber resilience, right? If I go to the, where's the clickers are there? So if you look at where money is being spent, okay, this is from the latest Gartner report. They did a survey of where money is being spent and how much budgets are increasing. The top two topics, cybersecurity and AI, right? So those are the top two topics, and that's where the budget is increasing a lot. Like that's where every company is spending a lot. What if you could do a data infrastructure that can be common for that provides cyber resilience and also provides what you need for building AI applications? And that is the concept I want to talk to you today. And this is something that I've been working on for a while. My company Cohesity, some people have known Veritas. Veritas is a part of Cohesity right now. And we've been working hard to help customers, and we found tremendous interest there. So something that I think you may find quite interesting. So to start with, what is cyber resilience? What is cyber resilience? Can anyone guess how many companies are getting attacked and actually breached in cyber every year? So in India, in 2022, there was a survey, and the answer was 74%. And many of you may already know, because cyber attacks are already happening. You might have had experience in your company. Billions and billions of attacks are happening all the time. But the key thing is, how can you recover from it? So if you have a business, you're getting attacked, attack succeeded, but you can restore, get up and running quickly in a matter of hours, then you're resilient. If you cannot, and if you're stuck in recovering for weeks, and probably the name comes out in the newspapers, then you're not cyber resilient, right? And so that is what cyber resilience is about. On the other hand, AI innovation is all about making sure you can develop AI applications cost effectively by accessing all data that you need for developing these applications. And these data needs to be clean, AI ready. And so the thesis I'm going to talk to about in the next 20 minutes is it is possible to build a single secure data platform that can power both of these applications, okay? So in order to go through that, I want to first talk about cyber resilience. And this is something maybe is not probably the main thing everybody's talking about, AI and agentic. This is really about how can companies bounce back from an attack that happens. And we'll talk about the basic requirements of a data architecture to get there. And then we'll figure out, hey, how can that be used also for delivering AI? So the fact of the matter, as I said, is there are billions of attempts happening, including bad actors, including nation states. It's a whole industry out there. There are people secretly having conferences like this, developing applications on how to hack, how to attack, how to break through. These are happening, and it's a big industry. And because the attempts are happening all the time, no matter what you do, it's going to get through someday. Some of the attempts will succeed, some data cyber attacks will occur. And it turns out recovering from a cyber attack is usually much worse than anticipated. Like we can plan for it. When it actually happens, it usually takes longer because we haven't thought through all the possible ways your cyber attacks could happen. In my company, at any point of time, we are talking to about 20 customers that are recovering from a cyber attack. Any point of time, any day. New attacks are happening constantly. We are helping them recover, and then they're up and running back, back again. So you need to do a lot of careful preparation in order to be resilient to those attacks. And from all of this, we have learned these 5 steps. The 5 steps any company infrastructure must be prepared in order to really bounce back and get up and running quickly to be cyber resilient. So I'm going to go through these 5 steps and come up with an architecture, and let's see how it maps to the AI data problem. First is you've got to protect all data with global governance, which means that you need a digital twin of your data, because if your primary gets lost, you need to restore the data back. So you need to have a copy of all the data. And people call it backups. Ideally, it's a digital twin. And this cannot be just once. It has to be done constantly. It has to be done quickly. And it has to be across all locations and all applications. Recently, when AWS East got down, so many applications went down. Because it was a single point of failure, you've got to have a backup where you can go recover from it. So in order to do that, you need a data infrastructure. The data infrastructure has a copy of all your data, which is your digital twin, and also your past copies. So you should go back to yesterday. You can go back to the week before, yesterday or a month before in the worst case. And so that is required. So all your data is in there, in files, in NAS, in VMs, in databases. That's where all your critical data is. You also need a separate infrastructure to have a copy of the data. So that is step number 1. Step number 2 is to make sure that copy doesn't get deleted. What is the point if you make a copy of all the data and it gets deleted? Turns out the bad actors know this. They know that you keep a copy of the data. So in cyber attacks, what we learn, first thing the attackers do is to go in and delete your data. So you got to make sure the data cannot really be lost. What does it mean is that the data is immutable, it cannot be changed, it needs to be secured and locked so it cannot be deleted, and you keep multiple copies, not just in one location, multiple media, and all banks probably have some tape copy as well, which is kind of slow to recover. But you need to have those copies. So it's not just that you need to have a digital twin of your data, but you need to have it in a way that it cannot be lost. It cannot be deleted. So that's step number 2. You need to have that. Step number 3 is you need to constantly monitor and making sure you can detect data anomalies, early indications of threat. So this data is constantly, this could be attacked. If it's being modified, you need to detect that. In fact, one of the things about AI is you need to preserve the data you're using to power your agents, because that could be poisoned, that could be corrupted, and that's actually a way to attack your business as well. So you need to be able to detect those attacks on data, changes in data, look for anomalies, even malware. It could be lurking in the data. So you need to constantly scan for it and keep the data clean. So that is the next thing. So you need to be cyber resilient, you need to have a copy of the data that is clean. You should constantly look for anomalies. Then the next is you need to practice recovery, right? So now you have a copy of the data, there is a threat that could come in. You really need to practice what will happen if a cyber attack happens. How do you recover? How long does it take for you to find the clean copy? So one of the most common things that happen in a cyber attack is attack happens, you recover yesterday's data. Turns out yesterday's data already has malware. So you're again reinfected. How do you get to the clean state? How do you get to a copy of the data that is clean such that when you restore it, you're not going to get reinfected? There could be backdoors in your infrastructure that could be opened if you restore data with those backdoors. And so you need to practice that, which means you need to create a separate environment where you can recover the data, scan it for malware, scan it for threats, validate that the applications come up, and then you know how long it takes to recover. If you find any problems, you go fix it. So this is an essential step. You can't do anything that you don't practice, right? Anything that you don't practice, you can't do it well when you're called in to do something. So that requires a whole set of automation. So you need to be able to automatically restore the data, automatically clean the data, automatically validate that the data is correct and it's restorable. So tons of automation is required. And last but definitely not least, you need to make sure you know where the sensitive data lies. That is, you need to understand whether you have PII data, maybe customer information, is it in the wrong location? You need to understand what the data estate. You need to understand who can access that data. Who can, for example, is there a copy of data with PII that could be accessed by a lot of people? And people would have forgotten it. Maybe the permissions were set wrong. Why is it important? Because when a cyber attack happens, another way that they could really threaten you is to steal the data, right? Steal the data and regulatory fines. If you lose PII customer information, you will need to pay hefty regulatory fines. So an essential component of having a cyber resilient architecture is to understand your data, where it lies, to classify it, make sure you know the PII regulated data like Aadhaar card numbers, and those things are always safeguarded and you know where they are. So the last component is you need to have a data classification technology that knows where the data is, whether the data is in a risky posture or not. And once you find something that is in a wrong place, you should be able to restore it. So these are all the essential components of a cyber resilient architecture. So you have your data that is running in applications. You have a copy of the data, a digital twin that cannot be deleted. You have multiple, you can go back in time if you need to. You detect for malware and make sure the data is clean. You know how to restore it with automation. You also know where sensitive data lies. And this system actually is deployed. In fact, many of you might be deploying in the back end, depending on your IT teams that are deploying such architecture. In Cohesity, we develop such platforms. And this is what we call cyber resilient architecture for data. So you can recover the data in face of a cyber attack or a disaster, and you can do it quickly. Now, let's talk about AI innovation and what does it require to do AI-ready data, right? So AI-ready data is all about making sure you have the right data for your AI applications. And one thing that we hear from customers all the time, and you should probably comment about that, is data is located in lots of different places. Suppose you want to do a customer service, say an agent. The customer service agent requires data from your procedures and manuals, from past transcripts that have been good. It needs information about the customer. So there is data that it accesses across the board. It's in multiple locations and multiple applications. Specifically, when you're developing Gen AI applications and agents, you're talking about unstructured data. So you could be using a data lake, to power data for your agents, but the data lake may not have all your contract documents, or it may not have all the user documentation that you need for customers. And because a lot of that data is unstructured and it's probably not available in your data lake. Plus, if you look at S3, many of your companies may be using S3 or an object store or NAS for storing a bunch of data. Do you have full visibility into what is out there? And whether you can actually take the data and actually use it as is? Does it clean of PII? Does it actually have information that you should not be exposing it to your agents? So it's difficult to govern all the data, so bring it all together. And so in order to make the data AI ready, we have come up with a set of 4 requirements, right? First of all, you need to have all data accessible and fresh, right? So you need to have the fresh set of data that you can use for your agentic applications. And that needs to be updated. And in fact, many of you may actually be taking the data and copying and dumping into a special data lake that you create for your agents, and then you take it from there. The second thing, actually an important thing, I don't know if everyone is taking care of it, is ensure data is auditable. So suppose your agent is giving an answer that it should not give. Can you trace it back into the data and what caused it, right? Suppose you have a RAG application that is giving you an answer. But if you're just going directly against the primary data, the data is already changing. Can you go back and audit and say, okay, this application was developed on this particular copy of the data. This is the data that should not have been there. You can go back and check it. So you've got to make sure the data is auditable for you to really rely on being able to rely and correct and keep the application course corrected. Third is you don't want your agents to be leaking the information, right? So you don't want it to be leaking personally identifiable information to the wrong places. Like you can train it with your previous chat transcripts, but it should not go reveal some other customer's personal information or say date of birth or a name and so on. So you got to make sure in the training data or the RAG data that you use, there are no sensitive data. There is no data that that can reveal or cause you a regulatory breach. And last but not least, sovereign deployments, right? Many of you, in the banking sector, you're very specific about making sure the data does not leave your control. There is sovereignty about being in India. Then some of you may be using cloud as much, some of you may not be using cloud as much. So you need to have a way to deploy all of this, irrespective of cloud infrastructure, or should be completely contained in India. So if you look at all these AI-ready data requirements, there are multiple questions, right? So can you keep all your data accessible and refresh? Like, do you need a separate unstructured data lake? How do you keep the data auditable? What tools are needed to detect sensitive data and eliminate them from your training data? And how do you really deliver compliance, according to what regulations need? So it turns out, this is the picture we came out from the cyber resilience infrastructure. And the cyber resilient infrastructure can actually solve the similar problems that what you need for AI, right? First, so all data is refreshed and clean. So you already have, if you're building a cyber resilient infrastructure, you're maintaining a digital twin, a copy of all the data, and that is accessible immediately. So that's constantly you keep it refreshed all the time. And you can use the same data for training your AI applications too. Ensure data is auditable. So in your cyber resilience architecture, you would need to keep snapshots of the data across time. So as long as you're training on these snapshots, your data is auditable. You can go back and check what happened and what is the cause of a specific behavior, and you'll be able to trace that, and you'll be able to very quickly identify what's wrong. 3, of course, you want to be able to detect and remove sensitive data from your agent development. You don't want to be using PII in your RAG system to maybe leak some of those personally identifiable information. And so if you build a cyber resilient architecture, all these 3 actually come built in. And last but not least, sovereign deployments. As long as your cyber resilience tool can be deployed wherever you want, on premises or in the cloud, with the right set of controls, the same cyber resilient infrastructure can actually power your AI data lake, right? So that's a concept I want to bring in. And typically in your company, the cyber resilience is implemented by a separate team in IT, and there's a separate team actually building your data infrastructure. There is an opportunity to bring it together. In fact, we've been hearing a lot of interest from customers because the data is already being gathered. It's already in one place, already being classified. So bringing this together, at Cohesity, we developed an AI architecture. So the AI architecture starts with a cyber resilient architecture. And the cyber resilient architecture, we call it the AI data lake. So this is a copy of the data that's in time series, it's sensitive data, classified, all of them together. And on top of that, then we can build either our own application. In fact, we built our own application that provides search, a conversational chat, and also provides an agentic framework. So the stack includes the data and includes the application altogether. And this application can be connected to various ways of leveraging it. You can connect to Google, you can connect to Salesforce, you can connect to even Glean and other applications for consumption, or Slack, you can consume it from there. It includes a chatbot as well, right? Or if you're building your own agents, the data source for the agent, especially the unstructured data, right? So in your data lake, you already have probably databases. Tirthankar is going to talk about Oracle and various things. But if you have like petabytes of unstructured data that you really want to connect to your agents to using RAG, the AI data lake is available through this infrastructure. So this is the architecture that we have come up with, and we found some very interesting, I'll talk about one customer use case in the next few minutes. But let me actually walk you through a few screenshots to show how the tool actually looks like, right? So this is our AI architecture, and we call this application Gaia. And this is a conversational chatbot. You can ask questions of it. You can find the right set of data. The good thing is you don't have to do anything for connecting all the data. It already runs on Cohesity's data infrastructure. And Cohesity's data infrastructure is the most popular one in BFSI. In fact, in the US, all the big banks use our infrastructure to store all the data. Even in India, we have many larger banks, are our customers. And so this data is already being collected. It's a question of unlocking and opening this data so you can use it for AI. So adding a data set to this, you can query it on data sets. Adding a data set is super easy. You can actually go see here are the set of data sets that have already been created for the chatbot to work on. Could be same thing enabled to your agentic application too. If you want to add a new data set, you add a new data set and you say, okay, select your data set. You can actually browse from the whole host of things that are already being collected for cyber resilience. It could be your SharePoint. It could be your on-premises NAS devices. It could be your virtual machines and databases as well when you do substructured data. In this case, it's Amazon in the cloud. You can select what you want to do this agentic framework to work on. And then you have a whole choice of working on a whole set of permissions. How frequently do you want it to be indexed to be updated, right? Continuously updated. It also automatically figures out PII. In this particular case, it was developed for the US compliance. The HIPAA and PII, US PII automatically gets detected and redacted. You can specify that. Plus, you can specify permissions. And the most important thing is, having this whole, copy a digital twin of your data. Who can see what? You can define your own permission rules, or you can go with the source permissions, what has already been configured in the system. And once you configure all of that, the data is already there. It's able to extract that, index that, create a vector database of it, and you can query it through MCP, or you can also query it through a chatbot. And in this particular case, of course, you can ask any questions. It's just like ChatGPT. You can ask any questions. But when you ask specific questions, in this case, what is somebody's tax ID number, and like our health beneficiary number, it's going to just redact that number. Right? It's not going to reveal it. Even if the data has it, if somebody finds out there's actually this data in there, it's not going to reveal that. And similarly, you can do more investigation. What happened with the specific case? Why is this submitted in the US? This ITIN instead of SSN, social security number, and it's going to give you the right explanation, but it will not reveal the personally identifiable number. So that is how, many of your infrastructure already includes, this most likely a cyber resilient infrastructure. You're already having backups. And if you have the right platform like Cohesity, you can actually unlock it and use it without having to copy all the data. You can unlock it for your agentic applications and implement secure AI, right? So this is how a single infrastructure that's already being used for cyber resilience could actually be a way for you to integrate data across all your applications and enable it for agentic deployment. And lastly, I want to leave it, we have a success story at a European customer, and this customer wanted this whole, is already using Cohesity Data Platform for cyber resilience, right? And they wanted to unlock, they have tons of internal meeting rules and regulations that they want to understand what happened in the past, why something happened in the past, and to make policy decisions and so on. but then they are a government customer, so they cannot really use any cloud. Of course, they want to be cyber resilient as well. So in one infrastructure, we were able to actually get all of this problem solved. We created a private GPT for them. It runs on on-premises GPU hardware, their own preferred vendor. We can plug in whatever LLM they need. And we created a secure, sovereign, unified access to data and roll it across their entire organization. And the thing is, the business value is fast deployment, because getting all the data together in one place, making sure it's cleaned and replicated, is actually an expensive affair. You need to actually create a data lake and be able to make it operational. But then, because the cyber resilient infrastructure already has all the data, it's extremely easy to roll it out to production. It reduced cost. You don't have a separate infrastructure for data. And lastly, this can also enable future agentic applications. And so that's my presentation for today. And the takeaway is that you have to be cyber resilient. And that requires keeping a copy of the data and make sure you can recover. And the same infrastructure can be used for powering your agentic applications. And so that is my presentation. Hope you like it, and love to get your follow-ups from you. And in any case, that you have any questions. Thank you.
Thank you so much, Vasu. Once again, can we have a round of applause for Vasu for that wonderful session?
Thank you.
To give a token of appreciation to Vasu, I take this opportunity and welcome on the stage the Chief Economist, L&T Finance. Please put your hands together for Ms. Rajni Thakur. Guys, a round of applause. You guys can do better. Come on.
Really, very, very good.
Thank you. Thank you very much. Thank you very much. Really appreciate it.
Thank you, Rajni, for doing the honors. Thank you, Vasu, for that amazing session. It was worth
Thank
it.
you.
Worth it. Thank you so much. So, ladies and gentlemen, our next session is Oracle AI for Data, where data meets intelligence, focusing on how AI is being embedded directly into mission-critical data systems. Our speaker, ladies and gentlemen, is Tirthankar Lahiri, Senior Vice President, Mission Critical Data and AI Engines at Oracle America. He leads the team responsible for building the core data platform that powers some of the world's largest enterprises. Tirthankar has 30 years of experience in database industry, and he has worked on a variety of areas such as performance, scalability, manageability, caching, in-memory, architectures, and developer-focused functionality. Please join me in welcoming on the stage Tirthankar Lahiri. Come on, ladies and gentlemen, let's have a round of applause for Tirthankar.
Thank you, thank you.
Welcome.
Well, all right, great, wonderful. I have 7 extra minutes. I have a lot of slides. I have enough for 2 hours of presentation, actually, in this content. It really depends on how much you would want to hear about this stuff. And the next speaker is a friend of mine, so I'd like to keep him as a friend. So I'll try to finish on time, but I'm going to burn my entire slot in the deep, so just be aware. You won't get extra time. I'm going to take it. Okay, so let's talk about AI for data and how we bring intelligence to data. It's a match made in heaven. And I'll give you some tips and pointers about surviving this really exciting transformation in technology. So AI is a thing. It's more than a thing. It's changing everything, as you all know. And it's not something that you can sit out. There are some technology trends you can say, let's wait to see if it happens or not. This one, you can't wait. You have to respond to it now. The quote that I like the best that I've heard about AI, there's a lot of doomsayers say AI will just wipe out the civilization. It'll replace all humans. I don't buy all of that, but this, I think, is really true. That AI won't replace humans, but humans with AI will replace humans without AI. That is going to happen. And the same thing is true for enterprises. Enterprises with AI will destroy enterprises without AI. That's without a doubt. So how do you address that? The key thing to do is you have to transform yourself and your enterprise into being an AI leader, and to use AI for what it's good for, to deliver insights, innovations, productivity, before your competitors. In this race, there's no second place. You've got to be the winner to remain relevant in the future. So this is, why, this is such an important, monumental revolution. The good thing is, in Oracle, we have AI for data that gives you the tools to do exactly that. And hopefully you appreciate that what we have done is actually very simple. It's very easy to learn and very easy to use. Doesn't require a huge amount of expertise to understand and deploy. Because what we have done is taken an approach which I think should appeal to customers who think strategically. Folks who understand that gluing many products together leads to endless complexity and cost. It's a never-ending chase for complexity. And customers who believe that open standards are essential for creating a competitive ecosystem that benefits everyone. Oracle Database has a converged architecture that is based on open standards with best-of-breed support for all workloads and data types. And we are extending the same strategy to AI for data. We believe that AI and data have to be architected together. AI and data, AI and app dev, as well as AI and open standards. So let's talk about AI and data being architected together. So this is manifested in our latest release, which is Oracle Database 26 AI, which is the world's first AI-native enterprise database, with pervasive, extensive use of the key AI technologies, which are LLMs and AI vectors. It also has many new and improved AI capabilities. It is also a long-term support release that replaces Oracle Database 23 AI. We are also enhancing Oracle Database 19c that many of you may already have in production with AI-ready capabilities. But 26 AI is our AI-native database. And the magic underlying this is the concept of the AI vector. Vector is actually very simple as a concept and incredibly powerful. Vectors are basically a sequence of numbers that represent the semantics or the meaning of complex objects, such as documents or images or even relational data. They're produced by deep learning models, which can be invoked directly within Oracle Database. So you can take your image or your picture, video, or your sound file or a relational document and produce a vector from it. Now, why is this important? This is because if you look at what databases have done traditionally, they traditionally analyze and search for data by values. Like finding the total sales for each product, it's a simple job for a database, easy, no problem at all. What vectors let you now do is to search for data that is semantically similar. Because, very simply, vectors for more similar data are closer together. And this allows you very easily to store vectors and search for closer vectors to find similar products. So you can see from this picture, the apple and the pear are similar and different from a plushy tiger toy. That's easy to do using vector search now. We have added sophisticated vector indexes. I could spend the entire hour describing them to you, but I won't today. But suffice it to say, they allow you to do vector search in milliseconds. We have in-memory graph indexes for the fastest performance on in-memory data that fits in memory, or partition vector indexes that extend to data of unlimited size. So vector indexes give you vector search in milliseconds. Now, one important thing to note is for business applications, which most of you are interested in, you need business data as well as vector data to answer questions. It's not just vectors. You need to use both so that AI can make informed decisions on business data, which means you have to combine that value-based search I mentioned at the beginning with vector search. And this is made very simple using Oracle AI database. So a simple question like, does my dental plan cover braces for my 19-year-old child? That question was first vectorized and then used to search for similar documents, but only for plans that the user is enrolled in. There's no point showing the user plans they're not enrolled for. And then once you have that, you can return those documents as results of that search. And this is a very simple SQL statement that does exactly that. And SQL is a very powerful language. We didn't need to make any changes to the actual language to support vector search. This returns the top 5 matching plan documents for the user that match the user's question. And this search runs in milliseconds, so you can run this both for transactional workloads and for analytic workloads. We have unified vector search with not just relational data, but Oracle database supports many kinds of data, and you can combine searches on text, spatial, XML, JSON, etc., with vector search without any problems. Now, vector search, one of the big use cases is for something we call RAG, Retrieval Augmented Generation. The relevant documents you found for the user, the plan documents, you can send those to a large language model to answer the actual question, because the vector search doesn't answer the question, just gives the matching documents. You can then call the LLM with the matching documents to say, hey, tell me exactly if there is a plan that would give my child coverage for braces if my child is 19 years old. That's the way RAG works. It's augmented with private knowledge found during vector search. I wanted to show you this quickly. I don't want to give you a SQL tutorial here. I know there's not enough time for that. But you can run all of RAG in a single SQL statement. It's pretty remarkable. And I've tried this myself, and I know this works. You first basically vectorize your question. Then you find the matching documents all using SQL, using vector search. Then you construct an LLM prompt in the same query. It's pretty impressive to me that SQL has this beautiful composable language that you can use to generate multi-step workflows. And then you can call the LLM with that prompt and get the response back, again using SQL. So again, don't worry about the detailed SQL statement syntax, but the point to show is that you can do all of RAG in a very simple way without writing any actual code. Of course, RAG is no longer sufficient, just vanilla RAG. You have to use AI agents to really get responses for complex scenarios. And AI agents use multi-step workflows to analyze data and to get data back from LLMs. And they use tools to take actions. Again, I'm not going to give an agent deep dive. I think every talk in this conference has some agentic components. But AI agents are the way to get basically beyond simple RAG. And one of the things we've done is to make sure Oracle database works with agentic frameworks in all the major hyperscalers and all the major agentic development frameworks. We are also making it easy to integrate agentic AI with Oracle database workloads. We have something called Select AI Agent. That's a query interface to agents. We are almost released a private agent factory if you want to build agents in your private ecosystems. And we're offering the ability to use MCP to interact directly with Oracle database. So all of these things are available or will be available very shortly. By making Oracle SQL available as an MCP server, it gives Claude or other LLMs direct access to the database to run agentic processing with. And with this capability, you can integrate with something like Claude Desktop and simply chat with the database, like a backend information repository, and Claude can run very sophisticated searches for you. This is a very simple example I'm showing here, but you can actually ask it to create reports, make predictions, generate summaries, etc., using this capability. One important thing that is required in this new world to succeed in AI is you have to be able to describe your data in a way that AI and humans can understand. Most enterprise apps, for anybody who's actually seen an enterprise schema, are incomprehensible to the end user. They have table names that are machine-generated, column names that are cryptic, and if a human being can't understand a schema, neither can AI. So we've added something called annotations that allow you to add additional context for schema elements without making schema changes. So you can say, for instance, that column that's called PN, which is meaningless to me and to most AI by itself, is actually a phone number. This gives LLMs more information with which they can generate the right SQL. And this is available both in our AI database as well as in the 19C database. In fact, annotating data is going to become the new way you tune SQL. Tuning SQL in the past required you to be an optimizer expert. Now, SQL tuning really for AI requires explaining the data to LLM so that they can understand how to make the best use of the data. Okay. Agentic AI is not, it's of course very powerful. And again, I could spend all day on this as well. It can combine data from multiple sources. You don't have to be limited just to database resident data with the agentic frameworks we have. If I have a question like, what is our share of the product, a certain product compared to the market, that can actually use database resident data and combine it with information found from the web, where there's a variety of data sources that it can consult. So all of this can be done using agentic AI, whether you build it with Oracle database or use external frameworks to build them. Also, we're working on making agentic assistance available for Oracle database users, because Oracle database is a sophisticated product and managing it requires expertise. We're trying to make it easy by providing management assistance, security assistance, knowledge assistance, etc., that help database administrators and end users get more productive use of the Oracle database assets. And each agent is built using a different strategy for data and AI interactions to get the best outcomes. But these are all being built, again, using our own AI agentic frameworks. OK, now, one really important thing in Oracle database is we've always been about being mission critical. That's why we run the largest banks in the world and in India. And because of this, our AI capabilities also benefit. So our vector database supports benefits from disaster recovery, transaction security that the dedicated vector databases do not have, because they're new, they're still in very early stage development in most cases. This stuff was built over decades. And on day one, we have the full mission-critical support of Oracle's infrastructure in providing all of these capabilities without having to reinvent anything. So our vector support automatically gets parallelization and scale out and DR, et cetera. Again, I can spend all day on this slide telling you all about the different AI features we have, but I think Indradeep will not be happy, and I want to keep him as a friend after this. It's actually interesting. Vasu, I, and Indradeep are both from the same IIT, both around the same time frame, so I think we want to be nice to each other. That's one of my goals. I don't want to run into his time slot. But there's a ton of stuff in Oracle AI database to do with vectors and AI in general. But let me move on to something else beyond just database-centric concepts. Let's talk about integrating AI for data with app dev. Now, what does that mean for enterprise apps? All of us want this to be the future or the present. We want to tell AI, I want an app to do X, and I want AI to produce the app for me, right? Now, how realistic is this? We've all seen videos of miraculous AI app generation capabilities. Amazing, right? Much faster than human beings. There is a problem for enterprise applications, because enterprises can only deploy applications that they can really trust to be secure, correct, and dependable. You can tell AI anything you want. But AI is like a very intelligent teenager, I think. Extremely intelligent teenager, who knows everything and always has an answer, never thinks it's wrong, but doesn't always follow the instructions given to it. You really can't run core banking with an app like that. It's not possible, right? You can sort of help a little by adding guardrails, but guardrails aren't sufficient. They're after the fact. I call it, you need hard rails. You need like rail tracks that the AI cannot deviate from if you want to trust the outcome of AI. And we refer to these technologies and these techniques as generative development, or GenDev. And again, this is not Oracle database specific. This is a general concept we're trying to make mainstream. It's really common sense that you need to engineer trust into the system. You can't do it after the fact. You can't take untrusted output and then try to trust it. It doesn't work. And the important thing is, GenDev requires the output of AI to be verifiable. If it is not, the enterprise cannot trust it. If you give me 20,000 lines of Python or JavaScript code, I can't tell if it's correct or wrong. It's impossible. If you give me 50 lines of SQL, I can do a better job. We're working on something called an open application specification language, which is also solution-centric, that is human verifiable. So GenDev's goal is to produce these intermediate languages, which are more solution-centric and easier for people to actually comprehend. That's the philosophy of GenDev. Now, again, understandability is good, but it isn't sufficient either by itself, because there's additional risks that AI introduces at the data level and the app level that need to be mitigated. Unfortunately, I won't have time to go through this in detail, but let me give you a quick tour of these problems and a solution outline. So let's talk about data risks from AI. What can AI do wrong? Or for that matter, even a human being. If I just let humans write arbitrary SQL, what could go wrong? They could break correctness. They could break data consistency. They could break the evolvability of data by exposing the underlying formats to the application, which is a very bad idea. If you expose the table structure to the end app, then you're stuck with that table structure without making significant app changes. Most importantly, you can break data privacy by leaking data you should not leak. There is a great technology in Database 26 AI, which I'm very proud of, but again, I don't have time to go into it today. It is called JSON relational duality. This is essential to prevent data risks for AI. What JSON relational duality does, it takes a very complex relational schema and produces updatable duality views that manifest the data in terms of JSON documents and JSON objects. So a purchase order will look like a purchase order document, a simple JSON document, but underneath it could be spread across many tables. This ensures consistency. It validates all the business logic required when you do reads and writes. And most importantly, the underlying table structure is not exposed to the application. So this gives you like an API that is guaranteed to be correct. And this is key for trusting AI-generated solutions. You can look up JSON duality online. There's lots of literature on it. But it's a foundational technology for GenDev. Privacy is a big deal. I don't have to tell all of you this. You all know this. If you divulge private data, you can go to jail. It's like really risky if you're dealing with corporate enterprise data, especially things like finance or healthcare. You can't divulge private data. And if you implement privacy in the app, there's a major problem with this. The problem is, again, you can tell AI the rules for privacy. Again, it may not follow the rules. And if the AI is given direct database access, it'll bypass all the app tier rules. So app privacy doesn't work in the age of AI anymore. The only way to do this correctly is to implement privacy rules inside the database. So you have to lock the doors inside of your house, for instance, to prevent movements that you don't want to authorize. You can't just tell people, don't go here, don't go there. You have to actually put the locks at the data source. And once you've done that, AI has to follow those rules. If AI generates some rogue SQL, that rogue SQL can't see unauthorized data because data is restricted from use. This is something called full stack data security in Oracle database. This is something you need, again, to be able to trust AI solutions. Okay? Now let's talk about, very quickly, how you minimize application-level risks by AI. Again, LLMs, I don't have to belabor this point. There's many things that can go wrong with LLM-generated code. You can be malicious. You can just be incorrect, or you can hallucinate. All of these things can go wrong. So what we want to do with GenDev is to use LLMs in a restricted sense, not in a free-form sense, to author arbitrary code. We want to restrict the usage, the results, and be able to validate why the output was a certain way. That's very important. And we have something called trusted answer search as an example of this, where a person wants to search for reports in a database. First of all, the search space is bounded, and the answer is going to be one of the reports in the database. So it uses vector search, not LLMs, to actually find the right report and to populate the report input fields. The LLM is not in the picture in this search. You can use LLMs to generate the report and to basically guide the report content, but the search is done deterministically through vector search. That's an example of using LLMs in the right way. We're not using it to create creative answers here. Very simple. You take a question, I have 50 reports, it'll give me one of the reports to run. The worst thing I might get is the wrong report, but I won't get some random answer completely. I don't know if any of you here use Oracle Apex. It's a visual IDE for generating application code, very popular. Many applications use Apex today. Apex allows you to use LLMs, again, in a limited sense, where given an end user question, you can map it to a report and then apply filters, groupings, etc., that the user can verify. So again, it's not arbitrary. The outputs are restricted to a set of reports. You can't ask it the meaning of life. It won't answer it. It'll only give you one of the reports in Apex and then try to populate the fields in Apex so that you get the right report drill down. So it's an example, again, of using LLMs in a constrained sense. So I talked about reports, but you can also use AI to generate full application. That's the really interesting part. Again, lack of time, I'm going to have to speed through this quickly. We are working on something called an open application specification language, which basically describes what the application should do, but not how to actually do it. So LLMs can now generate this, and I can then say, yes, this is what I wanted. Once I sign off, open app spec can be used to generate the actual Apex screens deterministically. So again, it's like SQL. It's much simpler than Python or JavaScript code, and users can verify it. It's much more compact. So in that sense, it's a better fit for you for AI-powered development. So this is an example. Just again, in the interest of time, I'm mindful of the timer here, although I think I have a few more minutes left, though. Simple example. It shows you that I want a report that does sales over time, and I want the report to be of this particular style, and this is a SQL query. So this is something an end user can actually verify. And then from that, you can generate that corresponding Apex screen that tells you what the actual summary sales was. Does this make sense? So it's, again, GenDev. The output on the left is the output of the LLM. And this, even I could verify, but there's no code there. It's a simple description of the report. And then from that, you can say, deploy this and create the report screen in Apex. So that's an example of GenDev put to use. Very quickly, since I'm running out of time, do I have a few minutes left, or am I really at the end of the hour? I have a few minutes. OK, so then maybe I can slow down a bit in that case. OK, open standards. This is very, very important. One thing is AI developers are different from traditional application developers. And so we've recognized that, and we felt open standards are paramount in allowing Oracle database to be used for data-centric AI workloads. So one of the goals we have is to support all the leading AI models, all the leading frameworks. We call ourselves AI secularists. You can use Gemini, Claude, ChatGPT, no problem. We don't restrict LLM usage. You can use your AI frameworks of choice. We have adapters from all of these to call into Oracle database. We also have a private AI services container we're delivering very soon, where if you are a sensitive customer and don't want to ship data to a third-party LLM, you can deploy this container with a private instance of Llama, for instance, that you can communicate with using REST calls to avoid sharing data with third-party services. So again, full flexibility, cloud-hosted solutions, on-premises solutions, private clouds, it's entirely your choice. And Oracle database basically runs everywhere, which means Oracle AI for data is also available everywhere. We run on all the major hyperscalers. We have multi-cloud integration with Azure, AWS, and GCP. Many of our large customers deploy what we call cloud at customer, which is a cloud running within the data center premise of the customer, but is managed like a public cloud. And this runs on state-of-the-art Exadata hardware that gives it the best database performance. And of course, many customers just have gigantic fleets of Oracle installations running on their own privately managed infrastructure. And we support that as well with Exadata and the Oracle Database Appliance. So ideally, this means that you can take AI for data and run it in any environment. And many customers are going through a cloud transition themselves, so they can begin on premises and then move to the cloud as they're ready, when they're ready to move to the cloud. So we support any stage of cloud evolution for customers. I think I actually covered everything I planned to cover for the most part. I only had to skip a couple of slides, so it's good. I'm glad I got the extra time with Vasu. See, Vasu is a good friend. This is what IIT is all about. It's all about fraternity and friendship. So I want to give Indradeep a few more minutes too. So let me wrap up very quickly. Again, to summarize, you have to really strive to be an AI leader. If you strive to be an AI follower, you will lose. There's simply no way to do that. You have to be ahead of your competition. You need to use AI to deliver breakthrough insights, innovations, and productivity. And you've got to do it before your competitors do. Again, so don't wait. Don't wait. AI projects, yes, there's talk about AI projects failing. Don't pay attention to that. That failure measurement, by the way, had a very high bar. And projects take time to prove themselves. But every time I've seen AI projects being done with Oracle AI for data, they have succeeded. It's taken time sometimes, but they have succeeded. So don't give up and keep pushing on the AI journey. And with that, I think I'd like to wrap up. Thank you very much for your time. Thank you for attending.
Well, thank you, Mr. Larry, for that wonderful, insightful session. Your perspective on integrating AI directly into mission-critical data system is highly relevant and actionable. Thank you so much.
Thank you, thank you.
And to present the token of appreciation, I take this opportunity and invite the Chief Legal Officer, L&T Finance. Please welcome on the stage, Ms. Aparna Rawat. Welcome, ma'am.
Thank you. Thank you. We have to work together. Thank you.
So, ladies and gentlemen, our next session focuses on fintech offerings and research at Fujitsu, the current landscape and where innovation is heading. Our speaker, ladies and gentlemen, Dr. Indradeep Ghosh, is the CEO at Fujitsu Research of America. He leads the advanced research efforts across AI, computing, and financial technologies. With a strong focus on translating research into real-world solutions, he has been working in the industrial R&D for over 27 years in various areas of hardware and software analysis. Please put your hands together and welcome Dr. Indradeep Ghosh. Welcome, sir.
Thank you. Good afternoon, everyone. And thank you to all the conference organizers for inviting me to this wonderful event over here in Mumbai. I'm going to today talk to you about Fujitsu's research and innovation and how we are applying all that to fintech, especially in the AI domain. So first of all, before I go into the details of what we are doing, I want to give you a brief overview of Fujitsu, because Fujitsu doesn't have a big footprint inside India yet. So the Fujitsu Group is a global IT company. It was established in 1935, so we have been around for quite some time now. We have a revenue of about $30 billion, and we spend about $2.5 billion per year on R&D.
And the Fujitsu Research Division, to which I belong, has a budget of about $1 billion per year and has about 1,500 employees worldwide. We call ourselves a digital transformation company, so system building and integration, but that's slowly evolving, and I'm going to talk to you about that too. And we happen to be the #1 IT services company in Japan, 125,000 employees. We are there in over 180 countries. And then going to the Fujitsu research part, so that itself is also a global organization. So they started off in Japan in 1960s, then came to the United States. So we have research labs in US and in Canada, and then to Europe. And actually, you'll be happy to know our latest research lab has been established in 1922 in Bangalore, and it has seen phenomenal growth. So it has now almost 300 researchers working there, and it's still growing. So I am actually in charge of all Fujitsu's research activities in North America. We call it Fujitsu Research of America. And we have three facilities. So the first one, of course, is the headquarters in Santa Clara, where I am. And then there is a small satellite lab with Carnegie Mellon University in Pittsburgh. So we collaborate a lot with universities to get our research ideas into business. And we also have a small satellite lab with University of Toronto in Toronto. And I took over the reins of this company about 2.5 years back. And I have been there since, and I'm assisted by my CFO, Katagiri-san. So what do we do over there? So, of course, these are the 5 pillars that we are actually working on right now in technology. So, of course, AI, which is a big part of our research. We work in computing, both in the classical as well as quantum computing. We have created Japan's first quantum computer in 2023, and we are scaling it up now. We also work in data and security, and we work in converging technologies, which is a marriage between technology, twin technology, and as well as social aspects. So Fujitsu's vision is to make the world more sustainable by building trust in society through innovation. And that is what our core technology is all about. So once we create this technology, we have this Fujitsu Uvance division, which has all these verticals like sustainable manufacturing, digital shifts, consumer experience, and so on, business applications, which tries to take the technology and applies it into those vertical areas in business. And then we have our technology and strategy vision. And the idea over here is to empower Fujitsu sales with cross-industry insights, enabling them to build meaningful client relationships and drive a mutually profitable growth with each other. And the goals are to create a collateral with a global framework that perpetually evolves with new technologies like AI as it is coming in. And we concentrate on these various areas of business like retail, energy and utilities, public sector, manufacturing, and the financial sector, of course. And so that's where I'm going to drill down a little bit. So what is the model? Our business, banking, financial services, and insurance vision. So you can see it's this 4-tier system. So at the very bottom is the technology that we're talking about. So we are doing the research in these various core areas for creating new IP, new innovation, and the tools that enhance efficiency to help us gain a competitive edge. And once we have created the technology, the Fujitsu Uvance division actually uses those technologies. It focuses on using AI cloud, data analytics, and creates sustainable and human-centric solutions. And on the third layer, we have the regulations. So the regulations are very important in the financial sector. We have regulations in IT, we have regulations in banking, financial markets, and these are crucial for ensuring security and transparency and trust. And finally, at the very top layer is our partner ecosystem. So these are all our customers with whom we go hand in hand to create various innovations and help them access emerging technologies. And this helps our clients stay ahead, enhance their services, and also improves their efficiency. So let's talk a little bit about all the technologies in AI that we have created. And then I'm going to talk about what those technologies are currently being used, especially in the fintech sector. Okay? So mainly, the technologies in AI, the core technologies, revolve around these two silos that we have created. So on the left, you have Takane. So Takane is our LLM for business, which can be fine-tuned. So as you know, most of the LLMs that have come out of the Western world have been mostly trained on the English language. However, we need LLMs which are basically also fine-tuned in other native languages, like Japanese for a Japanese company. So this is the #1 in Japanese benchmark. So we have fine-tuned the LLM that was previously mostly done using English language for Japanese applications, and it has achieved great results on Japanese benchmarks. It also is very good for customer and environmental adaptability, for enterprise data understanding, and for behavioral reliability. And I'm going to talk about a little more details about all those things. And on the right, we have Kozuchi. So Kozuchi is an AI platform which is equipped with many cutting-edge technologies that we have created to create AI agents. So we have 90+ releases, more than 100+ contracts with various companies. And the features over here are speed, evolution, and easy for development, and transforming workflows with AI agents. And just to let you know, the Kozuchi actually in Japanese means a gavel. So it's like a magic gavel which helps you do things that otherwise wouldn't have been possible. Okay. So how did the evolution of AI happen in Fujitsu? So of course, last year in June, we started with generative AI. And in generative AI, basically what we are doing is somebody is basically prompting it and getting answers for it. That evolved quickly into AI agents. So in the AI agents, actually, they are kind of autonomous. They are doing stuff on their own. They understand the environment, and they have a plan to execute tasks to achieve your goals. And then one AI agent was not enough, so immediately after that, we started working on multi-AI agents so that these are agents which collaborate with each other to actually create different types of value and tasks for you. So that's what we are working on in the agentic space. So in the enterprise generative AI framework, we have the main crux is that we are trying to create LLMs which are customized for the customer. Okay? So we don't want to create a one-size-fits-all solution because of various issues. So one is customer environmental adaptability. So we want the most optimal model for the customer so that he doesn't have to spend a lot of resources to run that model in their hardware. We want to also understand the data of the customer, so specific data that the customer has, which we can actually employ in the AI model. And for this, we use something called a knowledge graph extended RAG. And finally, we also want the LLM to be very reliable. So we want behavioral reliability, and so we call that generative AI trust. And we have created technology for LLM vulnerability scanner and LLM guardrails. And I'm going to talk a little bit about that also in the coming slides. So Takane 2.0 is actually a bunch of models. Okay, so the AI market is very huge. As I said, one size doesn't fit all. It's fragmented into a wide variety of use cases in each industry. And so what we did was we created a variety of LLMs to suit different type of problems that our customer has. So at the very top, we have the very lightweight model, which we call Takane 2.0. It has only 7 billion parameters. Now, as you know, LLM models like the ChatGPT 5 or these big ones like Gemini Pro, they are known to have trillions, 5 to 10 trillion parameters. So 7 billion over there is basically a puny model. But even that actually can do various tasks very efficiently. And the idea over here is that if you can do a task very efficiently with a small LLM model, you don't need to spend huge amount of money on your hardware resources to run that model, to actually answer you questions that you do not need. So a banking sector customer, for example, would not need to know the answer of some history question, but a standard LLM will give them that answer. So that's the idea over here. So that's the smaller LLM model. Then we have an intermediate size LLM model, which is 32 billion parameters. And that is actually giving much better performance that LLMs have that used to have 100 billion parameters. And this is fine-tuned for one GPU installation. So it can run very efficiently in a single GPU environment. And finally, we have a 101 billion parameter model, which is our most powerful model. And that actually is fine-tuned for 2 GPU kind of installation. And so as you can see that matrix over there, we are actually playing in the right-hand corner where we want a highly efficient, customized model for our customers. And we are not really playing in the very large space of generalized models to do anything. Okay, and so now we come to the various technologies that we use to actually fine-tune our models for AI models for our customer needs. So one is knowledge reconstruction. So in the knowledge reconstruction, what we want to do is we want to just keep the parts of the model which are relevant to the customer's needs from knowledge point of view. So as I told you before, I mean, a standard big LLM can have knowledge about everything in the universe, like physics, chemistry, history, and so on. But a banking or financial customer may not need all that knowledge. The first step is to actually cut out all that extra stuff which is not needed for the current application and create a smaller model using knowledge reconstruction. After that, there is the step of model reconstruction. So as you know, transformers are currently the most prevalent models used for LLMs, but that is not the only model that is there. There are other models like Mamba or other new AI models which can also be used for LLMs, and they might be more suitable for use in certain applications. So we kind of work with our customer to figure out what LLM model actually best suits their needs and go to that particular model. And finally, there is this step about quantization. And so over there, what we are doing is we are using a much less precise parameters, and as a result, the model actually reduces in size quite a bit. So these are the technologies for actually creating smaller models which are fine-tuned for our customers' needs. And then we have also this technology, knowledge graph extended RAG. So there is a lot of corporate data which obviously general purpose LLMs cannot train on because they are private and they are secure and they are not available to the public. However, that data is kind of very unstructured. And also, a lot of it is never used, and it's very manual and inefficient. So we have this technology which creates a knowledge graph out of this type of unstructured data, which are mostly documents inside a customer's premise, and use that in a RAG environment, like retrieval augmented generation, to actually enhance their element. And this actually consists of 3 steps. So one is data structuring, then advanced analytics, which can identify similarities and contradictions between disparate knowledge, making it possible to perform tasks which were previously not possible. and it can also self-improve. So as we keep on using more and more of the system, actually the RAG, the knowledge graph RAG actually improves with new connections and new nodes. So in the financial sector, those are the technologies we created. So what are the challenges that we are going to solve? So most of these you have already heard about throughout this day over here, that in the financial sector we have risks, cybersecurity risks because of increasing attacks. We have a regulatory environment which poses a lot of kind of constraints on financial institutions to adhere to regulations. There is outdated infrastructure which needs to be modernized for AI tools to run. There are fraud rebels. Customer requires the most exciting and the latest experience, but for that we need to have AI security, AI governance. We have pressures on cost and margins. There is a lot of problem with talent shortage for actually AI and siloed data. So all these legacy systems, they are kind of siloed with data in various silos. So AI systems cannot work with all of them together. And then the business processes that have been used before were inefficient, and we need to modernize them. So these are all these challenges, and our approach in the finance sector is to build a resilient and sustainable financial ecosystem through customer centricity and experience, operational efficiency and agility. So basically, we look at organizations which need to optimize their processes, increase the speed and flexibility with which they operate. We want to manage their risk and also need to see that they comply with regulations. We create innovations for future research readiness, like all these new applications that are coming through AI. And then, of course, we have banks which must also adhere to sustainable growth practices like ESG imperatives. So our customer-driven approach is kind of a hand-holding approach. So first of all, we discover and empathize. So with the customer, we kind of do a deep dive analysis as to what the problem is. We go through, make some workshops. We quantify challenges and opportunities. Then we kind of co-design the solution where the customer actually gives us the domain knowledge and we give the customer the technology to create a prototype which we can then use as a proof of concept. Then we build and integrate that and run it on the customer premise using some agile sprints. With secure data migration and also create a set of APIs for the ecosystem for future expansion. And finally, we run that system in the customer premise with 24/7 support and transparent SLAs. And finally, we have innovate and grow together for future applications, like emerging technologies and so on. And we continue to create this kind of roadmap. So this is kind of the Fujitsu's business model. We are a digital transformation company, so we are customer-centric. We solve our customers' problems. We work together with them to actually customize our solutions to their challenges. So one of the things that is very pertinent to financial technology that we have created is a graph AI technology. So as you know, a graph AI or a graph neural network is a graph created from various types of knowledge or various types of data that we have within the customer's premise. And sometimes we need this graph neural network generated from the customer data to align with the LLM that the customer is using to create certain new functionalities. For example, to explain what is happening, better explain what is happening in the LLM. Why did it take a decision? Or to see the causes that led to a certain decision within an LLM. And also, this is the core engine that is used in the knowledge graph extended RAG. So this is something that we have created. And one of the applications of this graph LLM graph AI technology is detecting fraud in fintech. So fraud detection is a huge impact in fintech, and the AI detection system must be explainable. So it must tell why it has chosen something as a fraud. However, the number of fraudulent transactions are very small, so we have unbalanced data. So when we are training an LLM, because the fraudulent transaction data is so small as compared to the normal data, it's difficult to train an LLM like that. So if we have a poorly trained model, because the data is insufficient, it can give us false positives. So it will tell you that a fraud has happened, where no fraud has actually happened. So over here, that is where the graph AI capabilities come in. So we can use it both during real-time validations and also during offline validations. We can use the graph as a post hoc explainability method for AI systems using its nodes and its connections. We use the graph capabilities to implement new and more accurate scoring systems for maybe credit card transactions, and that will actually enhance our fraud detection system and give us much better output. And finally, we can use pattern matching to design and implement better and more reliable rules than what we had originally only in the LLM. So this is one example of our technology being used in the financial sector. I come to a few case studies. So one is this company, Informa DNB in Spain. So their challenges was they needed to apply AI in their database in a reliable and transparent way to reduce ever more sophisticated financial fraud. We worked with this customer with our explainable AI technology to mitigate their risks and bias through transparent methodology and transforming decision-making for all their 4.5 million customers. And the outcome was it complies with the EU standards, it guarantees trust in every stage of the process, and it reduces bias arising from data quality analysis. So this is case study one. In the second case study, this is a company, Mo Bagel Taiwan. It's a financial services company providing B2B payment services for small and medium-sized enterprises. So their challenges were their reliance on static financial data for credit evaluation along with manual approval of the process. This led to significant barriers leading to delays in loan approvals, increased risk from credit, and also missed business opportunities. So what we did was we integrated our AutoML technology with their AI Builder technology. The AutoML technology actually automatically creates customized AI models with their fine-tuned to their target, and they can actually experiment with them very rapidly to see which one fits their needs very well. And using this technology, actually, they reduced their default rates for loan applications by about 70%. They improved deal closure rates and customer satisfaction by accelerating the approval process by 10 to 20%. And they also avoided their workforce expansion because they could reduce the manual checking of the credit application process. And then finally, we have also MTF Finance. So this is not really an AI solution, but we actually worked with this company in New Zealand, which is used by various loan providers for vehicles and others to actually implement the Azure Databricks Lakehouse Accelerator, delivering a multi-source integration and secure and government data platform. So once we create this kind of infrastructure, then their data reporting latency can be reduced, the MTF Finance data team can be upskilled, and this actually leads to future proof for using this kind of infrastructure for future AI applications. Do I have a few more minutes? Okay. Okay, and then finally the fourth one, Trinidad and Tobago Trust. So this is again another AI infrastructure implementation. So they want to move away from the high maintenance and inflexible on-premise data centers and decided to go with a hybrid cloud approach and third-party cloud approach, and Fujitsu actually helped them to create such a cloud infrastructure using their tier 3 data center in Trinidad. So now they have high performance, high availability boost, it boosts productivity, off-island disaster recovery is ensured using business continuity, and scalable platform supports future AI applications and services. So all this actually case studies show us that we not only need to create AI solutions as itself, but we also need to upgrade infrastructure that is there in customers' premises in banking and financial sector to make them ready for the AI solutions. And finally, I come to this area of regulations and security. So the European AI Act, which was recently instituted, led to a lot of compliance burden for AI solutions for vendors. So we have worked with this partner called ACOS AI in Europe to create a bunch of tools, a suite of tools that helps companies navigate the European AI Act. We have an AI compliance assistant. We have an AI ethics impact assessment tool. We have an AI risk management tool, AI ethics for fairness tool that actually looks at bias inside the tools, and also a LLM bias diagnosis and disinformation detecting tool. So these are some of the tools that people can use also in the banking and financial sector, because this is across all AI applications. And then finally, security. This is again something which is prevalent across all AI applications, including banking and finance. And the idea over here is that the LLMs are vulnerable. They are prone to prompt injection attacks to give you answers which they are not supposed to give. And to mitigate this, we have created an LLM vulnerability scanner and LLM guardrails technology. So the idea over here is that we have about 7,700 proprietary ones for scanning attacks, for scanning the LLM, which we can analyze the LLM for. We can do better checking by using our adaptive prompting technology, which actually tries to break the LLM from security point of view. And once we have kind of figured out what are the vulnerabilities, we create a scan report. And using that scan report, we then extract guard rules from that scan report to actually now kind of bound the LLM so that these vulnerabilities are not there anymore. So these are some of the technologies which we have created for security. So coming to the end of the talk, evolving AI agents is going to change people's workplace and lifestyles. The network of people and AI agents will be integrated into every area of business, and fintech is no exception, and it will transform business strategies and the processes that go along with it. And our mission is to create ecosystems in which people, business, and society can work together and connect together with multi-AI agents to respond to social and business challenges. And we continue to work with our customers to transition from a digital transformation company to an AI transformation company. Thank you very much.
Thank you, Dr. Ghosh, for that wonderful session. Your perspective on the current fintech research landscape and where innovation is heading was sharp and very valuable. Thank you so much. And to present the token of appreciation to Dr. Indradeep Ghosh, I take this opportunity and invite the head digital application engineering. Put your hands together for Mr. Dhananjay Singh. Welcome, sir. Come on, ladies and gentlemen, everybody together, make some noise and have a round of applause for Dr. Ghosh. Thank you so much. Thank you so much. So with that, ladies and gentlemen, we move to a final session that focuses on AI and analytics in market regulation. Applications challenges, and insights. Our speaker for the session, ladies and gentlemen, is Professor Partha Kanjilal, the co-founder and chief scientist at ResearchCare. He brings a deep experience in applying advanced analytics to regulatory environments where accuracy and accountability are non-negotiable. A former professor at IIT Kharagpur and visiting scientist at the Harvard Medical School, he pioneered neural network optimization and advanced genetics modeling. Please join me in welcoming, ladies and gentlemen, Professor Partha Kanjilal. And also with us, ladies and gentlemen, let's welcome with a round of applause Dr. Devrag Banerjee.
So one very personal note. So when I was a undergrad student in IIT Kharagpur, Professor Kanjilal was my thesis advisor, and we together wrote what was my first published neural network paper. And even to this day, after 30 years, it is my paper with the highest number of citations.
Thank you.
So glad to have you here today.
Thank you. Thank you very much.
Thank you.
Hello, everybody. Thank you very much. Well, AI in market regulation is a very broad area. And this happens to be the last talk in this session. And I'm sure you folks are all saturated with inputs about AI. I will try to pass through the key glimpses of this interesting area. Okay, so what is the objective here? The key objective is that we protect investor interests and we provide market integrity. In US, as the SEC and FINRA are the two key organizations, two regulators that look after this space. And in India, we know that SEBI and RBI, these are the prime regulators looking after these these key objectives. Now, what are the regulators' jobs? They formulate and enforce rules, detect wrongdoings, discipline violators, broadly speaking. Now here, the interesting thing to note is that we are passing through a very interesting period in time. On one hand, we see phenomenal growth in the technology sector, and on the other hand, we see that India, now the fourth largest economy, and the fastest growing economy in the world. At the same time, that makes India a very lucrative place for fraudulent traders. Because with the advancement of technology and advancement of economy, obviously comes the burden of regulatory challenges. And our regulatory bodies are suddenly thrust with a lot of load of these regulatory challenges. Now, in terms of the increased load that we currently have, is that we can see that today, NSE is the third largest body in terms of the having to handle the cash equity sector, and in terms of the derivative sector, it is the body having the largest load of derivative trades. Now that itself shows that we have a tremendous amount of responsibility in handling violative efforts in the trading market. What is the obligation here? Now, anyone, whoever touches a trade, has the obligation to provide surveillance. That means whether it's a regulator, the exchange, or the broker-dealers, they all have to have their own surveillances running. And they have to establish and maintain and enforce trade and communication surveillances in all aspects of their handling of the trade. Let me now talk a little about market surveillance patterns. Well, what are patterns in general? I know that we have talked a lot about various aspects of modeling. Let me just say, in a very simplistic way, those who are new to this space. Now, suppose you have gone to a place where there are many birds, and you are asked to identify ducks. How do you do that? Well, you say that if it looks like a duck, if it walks like a duck, and if it quacks like a duck, then most probably it is a duck. So similarly, in the trading sector, when we are getting billions of trades coming or passing through our exchanges, it is the job of the analytics folks to look at the various aspects of these trades, look at the various features that constitute that trade, and from that, they have to identify the specifics that relate to a violative trade. Now, let me go over a very simple example of a market surveillance pattern, a wash trade pattern. Now, wash trade, what is the purpose here? The fraudulent trader is trying to give the market an impression of large volume. How does it do that? Well, they buy and sell the same stock, more or less at the same price, more or less at the same volume at the same time. So, for example, here we see 6 rows of data, and that basically are 6 different trades, and they are coming in pairs, buy and sell, more or less the same volume, same price, and same time. There may be some differences, but overall, there is no meaningful change in the ownership. We call it the beneficial ownership of the stock. Okay? So no economic substance in this activity. So this is a fraudulent activity. And to capture this, we will like to have a model. And how do we build a model for this? So we first identify the features. So say we can take 4 basic features here: the washed quantity, the difference in the quantity, the difference in the price, and the difference in the time. Okay. And so broadly speaking, we have first the features identified, then we put the weights for the features, and based on this, we find out the total score for the feature. Now, each feature is assigned a particular score, and then you compute the total score. Now, in real life, the problem is that in most cases, the vendor models and the models that are designed in-house, they are not scored. So if the models are not scored, the exceptions is very difficult to dig through the large number of exceptions to find out which ones are really violative and which ones are really deserve your attention. So the ground truth here is that all the exceptions that are captured by the exchanges, individual firms, broker-dealers, most of them are never analyzed. So people just don't look at those exceptions. They don't have time. They don't have the resources for that. So how is it that we see the enforcement actions? So basically, the enforcement actions are product from referrals. So someone is making money at the cost of someone losing money. So someone losing money complains to the exchange, and then exchange takes it up. And that's how the importance of the scoring lies. It is usually, if we are having a logic-based model, it may be that we won't have any scores. Usually, if you have a machine learning model, you have scores associated with the models. Let me look at another pattern, another simplistic pattern for scoring end-of-the-day trade. Why end-of-the-day trade? Well, this is end of the trade. That is the closing price on a particular day of a stock is very important because it can influence the valuation, it can influence the settlement, and the performance assessments of the portfolio is also dependent on that. If you can move the end of the price by 0.1%, that can make a few $1 million for some particular participant. So that's why end of the price is a very important component for the traders. So how can one manipulate this? Well, we are now capturing 4 different features in this particular case. One is a inverse square root function versus the time to close. So as you can see here, so the closer you are to the endpoint, which is on the left side, the higher the value of this particular feature. Okay. The second one is the time to end rank. Now, if your rank is higher, your score is higher. The third one is the percentage of market buy or sell volume. Now, this is a very important component. The more volume of the market you take at a particular time, over a period of time, the more influence you have on the price. So the percentage of market volume that you execute in the last second or last minute of the trade is very significant. And the fourth one is the market concentration. What does the market concentration mean? Suppose you are the only trader in the last minute of the trade. That means you have the 100% control over the closing price. So the market concentration is 1, very high. And suppose instead of 1, there are many participants. Then the percentage of market volume executed by individuals will be very small. And we use Herfindahl index, which is a summation of the square of the percentage market volume by the individuals. So with these 4 features, we can come up with a scoring of end of the day score for the particular participant. Now let us look at one real case of market manipulation. Now the story starts in 2023, January. Jane Street, a hedge fund, starts trading in India, and they start trading in a cross-product financial instrument. By cross-product, what is meant is that you are dealing with 2 different type of asset classes. So in this particular case, they were trading with Bank Nifty ETF. Now, Bank Nifty ETF happens to be a bit vulnerable ETF in India because it has 2 or 3 components. I think 3 components which make up about 60 or 80% of the ETF. The rest of the theme of the constituent of the ETF is relatively very insignificant. So what Jane Street started doing is that they had basically three different steps in their manipulative strategy. First, they start buying the security, that is the stock, and the futures from around 9:15 to about 12 o'clock. Okay? And then you can see that and then they start the second part of the strategy, that is the short options, that is they sell calls and buy puts. Now, when an analyst is looking at this, every piece of this thing that you see here is of importance. You can see that the options trade is starting a little after the equity trade starts. Because why is so? What is happening is that after you start buying the equity, your equity price starts shooting up. As the equity price starts shooting up, the option price also will start shooting up. And you are wanting to sell the calls. That means you want someone to buy your calls. So as the option price starts shooting up, people will think that the option price will go higher and higher. So there is more interest in that product. Now here, what is going on is that in particularly Jane Street case, we are seeing that their buy volume is something like 4,370 crore. It's quite a large volume of equity and futures they're buying at a very aggressive rate. How are they doing that? Well, they are buying at higher than the market price just to push the price up. And they are taking an insanely large options position. 32,000 crores of options position in one part of the day, morning of the day. Now this snapshot that you see here belongs to January 17, 2024. They started in 2023. In the year 2023, they made $1 billion profit. Indian regulators didn't know about it. Okay. Now, 2024, the story looks like this. On this particular day, so they were lucky to make a profit of 735 crore in one day. So, as I was saying, first the stock price goes up in the morning half, and then after 12, they start selling the stock, again aggressively selling the stock on the futures. That means you are selling at a price lower than the market price to bring down the value of the security. As far as the options is concerned, is not touched, because you know that as the price drops, then the option value also shoots up. I mean, options short position shoots up. So, end of the day, the market price for the stock and the future crashes, and the options position explodes to a very high value. Overall, the net profit is 735 crores. Now, when you look at this, it's happening 1 year after they started doing this manipulative trade. You can see that straight away you can see some red flags. First of all, they are doing quite a large equity execution, more than 4,000 crores, okay, in one half of the day, and taking 20% of the market. That means they have quite a large control on the price of that security at that point in time. Okay? Now they're taking an insanely large options position. Now usually, options position is taken for hedging purposes. Now hedge means the notional value of the underlying, in this particular case, stock and futures, and the notional price of the derivative, which is the options here, sort of should be comparable. Now here you see that the options price is 7 times. That itself is another red flag. And the third thing is the net profit. Now if in this industry, if you don't have any data, only if you have the profit, if you know the profit that the person is making every day, that itself conveys a lot of information. And if you can track the profit over a period of time, you can easily see a spike. On a particular day, there is a spike. Something is going wrong, right? Now, obviously, one can say that the SEBI was caught napping on the wheel, but no one can say that, well, we don't have a pattern. We don't have a pattern that captures this particular behavior. How do we know? Well, the fraudulent trader knows what patterns are normally used by the regulators. So they will not use the same pattern, not necessarily. So they'll be always tweaking the pattern. And when we're talking about a profit of 735 crore, we have to understand it's a zero-sum game. Someone is losing money. Someone is bleeding. And this is a silent war that goes on in the securities industry. Okay? And there are no problems. They have been doing it for the last 1 year, and they continue to do that until, by the sheer chance of luck that for the regulators, then that in April 2024, there was a legal battle that Jane Street got into with another hedge fund, Millennium, because the Millennium tried to poach these two folks who were doing this very profitable trade in India. And the judge was curious to know what was that very profitable trade in India. So they had to open up. And then the whole world came to know, and then SEBI also came to know. So what we learn from this, that, let me skip this in the interest of time. So basically what we're saying is that violative trades may be unique in nature, and you cannot expect that this will be captured by the type of surveillance that's normally run. But we have a responsibility to ensure market integrity. And when we are saying that India is 4th largest economy in the world, and we have the fastest growing economy in the world, with that comes a certain degree of responsibility to have a market with some sort of integrity. And there is no excuse, like we cannot say that we don't have this pattern. We've never seen this before. So there has to be some basic infrastructure, regulatory infrastructure that helps us detect any violative or abusive behavior of the traders. And this particular case, if we look at the percentage market volume taken, if we look at the fact that the securities being handled are such that one can be used to manipulate the other, that itself is a red flag. If you can, in addition to that, if you have something like a client analytics, like you have in KYC, normally we don't have in regulatory industry. If we know the history of the participants, what normally which securities they execute, what sort of volumes they do, what sort of percentage of the market they do, then that also could be another infrastructural help that the industries, the regulatory industries can have. So these are the different components that have to be built in addition to the conventional surveillance patterns. So then it becomes easier for or I would say that then the chances of capturing a violative trade is higher in such circumstances. There are other advantages, other components that are of interest. Obviously, data, we all know that particularly in US, they have a consolidated audit trail, they call it CAT, which is handled by FINRA, which has a complete history of each order and the execution. And that sort of thing is missing in here. But if we can do whatever we have to corral all the information that we have and then collect the information together, we can see some pattern emerging from that. And this is one thing that is important to note, that today, when we are saying that the technology is going ahead, the economy is surging and all that, we have to have minimum degree of coverage where the gaps lie in our regulatory system. For that, we don't necessarily have to have a very sophisticated guardrail. Even if we have some guardrail, some anomaly detection, some basic components, then we can at least have some red flags which can help us identify issues like this. So with that, I will wrap up. It's almost time. And this is the attitude of the folks who do violative trades. Thank you.
Thank you, Professor Kanchila. Let's have a round of applause for him. Ladies and gentlemen, the clear and insightful session, that was wonderful. Your perspective on applying AI and analytics in the regulated markets environment is highly valuable. Thank you so much. And to present the token of appreciation, I take this opportunity and invite on the stage the Head Treasury for L&T Finance. Put your hands together for Mr. Ravindra Gerasappa. Welcome, sir. We all can have a round of applause for the final session, ladies and gentlemen, by Professor Kanjilal.
Thank you.
Thank you so much, sir.
Thank you.
So, ladies and gentlemen, as we close today, let's be very clear about what we covered and what it means. Firstly, starting this lovely morning, we heard from Dr. Stephen Probst on how to build real data products powered by generative AI. Next up was Siavash M. Alamuti, who pushed us to look beyond the app economy towards the agentic economy. After that, it was Mr. Sanjay Krishnan, grounded us with the lessons from real enterprise AI agent deployment, how it actually works. Post that, it was Dr. Sriram Rajamani, who showed us how humans and AI can collaborate directly in code and spreadsheets. Post that, we had the battle pitch point with a wonderful jury where companies came in and pitched the ideas. Post that, we had a lovely masterclass with Swaminathan Iyer and Murari Ramuka on agentic AI in financial institutions. After that, we had Mr. Vasu Murthy, who made it very clear that AI innovations requires cyber-resilient data foundations. After that, we had Mr. Tirthankar Leri, who showed us how AI can be embedded directly into mission-critical data systems. Post that, we had Dr. Indradeep Ghosh, who mapped the current fintech research landscape and where innovation is going next. And finally, we had Professor Partha Kanjilal, who emphasized the realities of AI in regulated markets, where accuracy and accountability are not optional. The message from all these sessions were very consistent. AI is no longer experimental. Values come from architecture, integration, and execution. Winners will be the ones who move from demos to production. We thank all the speakers, our partners, our jury, and everybody who stayed engaged throughout the day. Can we have a round of applause for everybody who was a part of this? Well, this is just not the beginning of AI, ladies and gentlemen. This is the beginning of AI that actually works. Now, the moment you guys have been waiting for, the winner announcements. It's time for Empower AI, Pitch Point winners, and the Pearl Challenge winner felicitation. Now, this is not the place where it will happen. We have the winner announcement in the next ballroom. Best part is that the live streaming will also happen in the same place. In case if you want to sit here, you guys can sit here. In case you want to attend the session, which is right there, you can please go ahead and once again, thank you so much. Can we have a round of applause for everybody who was part of RAISE 2025? Come on, guys. This is your host, Sohail Kapadia, signing off. Until next time, keep learning, keep growing, and thank you once again. Thank you so much, sir.